So for this first problem here, we have the displacement because it talks about how the car moves 3 in one direction and 5 in another. So how we can find that is do 5 minus 3 meters equals the magnitude displacement, just 2 meters, which shows basically in general how much it moved. And for here, it's pretty simple, but we first have to convert. So we have here 95 gallons in 1 minute. We know that 1 minute equals 60 seconds, so that converts it already to seconds, and that 1 gal equals 231 inches to the third, and that we know 12 inches equals 1 foot. So we just have to multiply all of these together, and that result is going to give us 0.21166 feet to the third over seconds, which is going to give us answer A. So the answer here is C. The answer here is A. Now, for the sum of the vectors 1 and 2, so 1 is heading this way, and 2 is heading this way. So the sum of both of them together is going to be B. Now, here we have to show which car is speeding up, and that's going to be this car that starts at a speed and goes higher. So that's going to be A. Now here, none of the cars are reversing direction, so the answer is E. And here, which car is slowing down? None of the cars here are showing signs of slowing down either, so the answer is going to be E again. Now here, it says which car is not moving. That's B. It's remaining at a really constant velocity there, so it's not moving. So the answer is B. Here is for negative x. Here we know that x would be positive, and down here x is going to be negative. So since this is moving in a downwards direction, the answer is D. Now here, when you brake on dry pavement, your maximum acceleration is about 3 times greater than when you brake on wet pavement. For given an initial speed, how does your stopping distance x dry on dry pavement compare to your stopping distance on x wet? So we know that your maximum acceleration is 3 times greater when you brake on wet pavement. So if it's 3 times greater on dry, so we know that wet would be 1/3 of what the possibility could be. So we know that dry would be 1 times third of wet. So now for this one, the answer is going to be D, the height of the roof, because to determine how fast it's going to take to come down, we first have to know what the distance between the top and the ground would be. So that would help us determine that. And now for this one, if we have the initial direction 30 degrees below the horizontal, your friend throws the same initial speed in the direction of 30 degrees above the horizontal. When the rocks hit the water, they will both moving at the same speed because even though they have different placements, they're both hit it in the same direction.